Let's look at our first theorem. It's a very trivial theorem, and you'll see that the proof simply requires knowing the definitions. Knowing the definitions of what it means to be equal and what it means to be a subset. The theorem says that if A and B are two sets, then they are equal to each other. A equals B if and only if, this is my shorthand notation for if and only if, A is a subset of B and B is a subset of A. Frequently now, we'll use this theorem because if you're required to show that two sets are equal to each other, you first show that the left set is a subset of the right set, and then, case 2 maybe, you show that the right set is a subset of the left set. So, this, if and only if, can also be written with a double arrow. It means this implies this, and the right-hand side, that whole thing, when that's true, this is true. So we're going to do two cases. First, I'm going to do this direction, which means I'm going to assume this to be true and then prove that this is true. And then we'll do case 2 after that. So suppose that the left half is true. All right, well, if X is an element of A, then X is an element of B. How are we able to say that? Simply by the definition of what it means for A to equal B. Every element in A is also in B. Every element in B is also in A. That's the justification for this statement. So that's what a definition of A equals B. Thus, A is a subset of B. Since this X, this value of X, were chosen arbitrarily, and we proved it doesn't matter which one it is, if X is in A, then X is in B. That means every element of A is also in B. So A is a subset of B. Well, the next sentence is going to be just as simple. If X is in B, then X is in A. Again, by the definition of what it means for A to be equal to B. Thus, B is a subset of A. So we've proven the two things that we had to prove. And we're halfway done. Now let's take a look at this direction. Suppose A is a subset of B and B is a subset of A. You could almost just say, well, by the definition of equals, A is equal to B. Maybe I'll put a few words into it just to make it look like a real proof. Suppose A is a subset of B and B is a subset of A. And our goal is to prove that A is equal to B. Well, we have to show that if every element in A is also in B and every element of B is also in A, that's the definition of equals. So if X is an element of A, then X is an element of B. That's because A is a subset of B. This should say if. That follows from A being a subset of B. And maybe I'll indent it over here. If X is in B, then X is in A. Because of this statement right here. Every element in B is also in A. So essentially, we've shown, now I could put one more sentence in, which I don't think I'll do. We showed that every element of A is also in B, and every element of B is also in A. So I will just finish it off here by saying, therefore, A equals B. Again, that's such an obvious fact that it didn't require much of a proof, but I wanted to at least start us. This is our first proof, and I wanted to show that an if and only if proof requires two cases. You have to prove the arrow goes in that direction, the implication. If this is true, then this is true. And then the arrow going back that way means if this is true, then that's true.